everyone. I hope this is working. My name is Cami Williams. I work for Facebook Open Source. I'm a developer advocate. And welcome to the first ever live stream from this channel. Wow! I really hope you all can hear me. I really hope you all can see me. If you're watching, please say something in the chat so that way I know everything is working. But I assume if you're here, you either, one, know me in person and are my friend, hi, or two, you're interested in learning how to connect your PyTorch model to a web application using AWS SageMaker. If you have no idea why you're here and you're just bored during lunch or want to be here for the lulz, then hey, you've come to the right place. Tom is here. Hi, Tom. Thank you for watching. Yeah, so like I said, my name is Cami Williams. I have this cool title for myself here. Hope y'all like it. Worked on it in the last 10 minutes. I'm an open source developer advocate. I focus mostly on machine learning and artificial intelligence. And I recently wrote a blog post exactly about this video. And so if videos are not your jam and you like reading, you can check that out. It is currently on the Facebook for Developers blog, published yesterday, I think, or 2 days ago, not sure. But you can check all of this out here. It has all this information. You can also follow along. But I essentially wanted to take this live streaming series and walk through this blog post step by step, showcasing to you how to utilize AWS SageMaker, how to use your PyTorch model with that, and then other AWS services to connect a web app to. And then at the end, I will also be building the web app. I'm not a front-end developer, so that part is especially going to be rough and a learning experience for all of us. So stay tuned for that. But while we're here, let's just heckin' dive right in. Before we do though, I wanted to say make sure you subscribe to this YouTube channel to follow along with this series and more that's coming from the developer advocate team on Facebook Open Source. Follow us on Twitter. I'm sure if you're watching this, you probably already do, but please do so. It always helps. Wow, I feel like a super cringe YouTuber. I promise I'm not. I just like to code and I like to learn, and I hope that you all learn from how I learn and my mistakes along the way. So yeah, let's dive right in. So if you're curious about machine learning or what neural networks are, or anything of the like, I am definitely going to highlight some of those topics in this live stream, but I already created a video about it. If you want to go to the YouTube channel and just click on what are neural networks, you can get a nice debrief with that. But again, for this video, I'm going to assume that you have this base knowledge. At least have a good knowledge of how to understand what models are in theory, and then in practice in code we can go over that as well. So I also have a couple other blog posts that might be helpful to you. So I have this blog post on my Medium. It's an introduction to PyTorch by someone who doesn't know a ton about PyTorch. I wrote this when I first started at Facebook. But it essentially walks through how to create a model on the MNIST dataset. And you might not be familiar with what that is, but essentially the MNIST dataset is a collection of images of handwritten numbers. And the goal with creating this model is for the neural network to be able to identify what a handwritten number equates to numerically. So, for example, if in the model that is trained on this MNIST dataset, if I send in this image of the handwritten 5, then it would just come back with a 5. So we're going to be using this. The kind of web app that I want to create, I made a GIF of it down here. It's going to look like this kind of, but essentially the user will draw a number. that represents a digit of pi, and then that number, it might be a little bit difficult to see, it'll appear on the right. So it's not useful by any means beyond learning, but hey, you know what, that's why we're here. So again, if you're interested, you can follow along in this blog. I'm going to be referencing it time to time just to show you where we're at. I also recommend, looking at this blog post as well for how to build the model. I'm not going to build the model in this stream because it is definitely the, hello world data set of machine learning. But I'll show you the code and I'll step through it and we can learn with that together. So I want to just quickly show you what we're going to be using with AWS and how all of these pieces are connected. So the first thing, and I'm drawing with a mouse, so again, please forgive me, we're going to be having our PyTorch model. PyTorch. Oh gosh, this is going to be rough. I should have prepared ahead of time. We're going to have our PyTorch model hosted on SageMaker. So SageMaker is an AWS service. It does exactly as we described. It's for hosting your machine learning models and things of the like. I have exclusively used it with PyTorch. Always eager to learn more. They have a lot of great blog posts that you can utilize to get started with SageMaker. One thing I'll say about AWS, Amazon Web Services, is that there's a lot there. You can build a lot with it. But it can definitely get confusing. So SageMaker is definitely not the only service that we'll use. I'll try my best to explain each one. But basically we're going to have our PyTorch model hosted on SageMaker, and then we're going to have our web app, and I'll just call this Pi because it's our Pi web app. So the question is, once I have this model hosted, how do I have this talk to my web app and my web app talk to my model, and so on. So there are a couple services that we'll need to use in between. The first is a Lambda service. So the Lambda service is also going to be on AWS. This is essentially going to handle any incoming requests from the web app and any outgoing requests from the model. So it'll take requests in from the web app, send it to the model, and then go back and forth, vice versa. So boom, SageMaker talks to Lambda, Lambda talks to SageMaker, web app talks to Lambda. Now, unfortunately, with AWS Lambda, you need something to have pointed to it. A REST API is best, and so for that I have something just in between. And this is API Gateway. API Gateway is where we'll set up our REST API. I see the comments about the poor video quality. I'm really sorry. I don't have the best internet, and I'm not totally sure how I can fix it. But if anybody, has trouble seeing things, just let me know. I'll try and increase font size and whatnot. But yeah, sorry, bad internet, quarantine. This is life right now. So we'll start by utilizing SageMaker. That'll be our first point. Then we'll create our Lambda service. We'll create a REST API to connect to that Lambda service. And then finally, we'll create our web app to communicate with that. So you can kind of see the path I want to do with learning here. Hopefully we can accomplish something in the next 50 minutes. So again, if you're not familiar with PyTorch, it's pretty straightforward. You can go ahead and go to pytorch.org and see more information. There are some great tutorials here that can help you get started with not just PyTorch, but with the learning principles of machine learning. One quick thing I wanted to highlight here, this is Google Colab. Google Colab is similar to Jupyter Notebooks, if you know what Jupyter Notebooks is. If you don't know what either of them are, it's essentially a runnable IDE online. But what's nice about Colab is it's kind of perfect for experimenting with and creating models. You can change your runtime type to be a GPU or a TPU. GPU is almost always what I do. It just makes things run faster, especially as you're going through these data sets and training a model on hundreds of thousands of images or text or video or things of the like. You need a faster computer than your CPU, your laptop. So Colab makes that possible. AWS utilizes Jupyter Notebooks, but it's a very similar environment. So this is what I use when I just want to experiment. Kind of the most important concept to grasp from utilizing this data is tensors. Tensors are essentially arrays. For those of you who use programming nomenclature, if you're not familiar with that, it's an array is like a list of things. So you can see here if I have my array of one or a list of one thing, and I make a tensor behind it, the tensor is essentially something that says this is data, and this is data that I'll use to train my neural network on. They're pretty straightforward. You can see I did some math operations on each of these. Again, if you're interested in learning more about tensors and tensor manipulation, you can check out my Introduction to PyTorch blog post. But the reason why I wanted to introduce this concept is the tensor is what will house our image data. So for example, if I have a 128 by 128 image, the tensor would also match that. And essentially, for the MNIST, for the handwritten numbers, each spot in the array would be a 0 or a 1. A 0 representing a white pixel, a 1 representing a black pixel. And so the way training this model works is we take hundreds of images of handwritten numbers, convert them to these tensors, to arrays, and then have a number assigned to them. So that's the training phase where we have all of this data and it's all labeled. So a handwritten 1 will have a 1 label associated to it. So there are various algorithms you can utilize, to train these things. PyTorch is nice because it has different domain libraries that help you do that. So there's Torch Vision, there's Torch Text, there's Torch Audio. All of it is pretty intuitively named, but we use Torch Vision to help us train images. There are different, like I said, algorithms. You can use a convolutional neural network. If you're interested in reading on that, you can. But essentially, like I said, you have this data, you go through a training phase. There are different epochs that you go through with training. That's essentially how many times something is trained. And then the accuracy increases with each epoch. So if you have 100 epochs, then it will probably get very, very accurate. And then you have a testing phase with the neural network. The testing phase is where you use unlabeled images. You know the label, but the neural network doesn't. You run those images through your neural network, and if they come back with the correct result, then great. Otherwise, you adjust and optimize your algorithm. And then once the accuracy and testing is up to par with your expectations, then your neural network is ready to use and ready to go. So it's pretty much that simple. I'll quickly show you the code for how to do that with this MNIST dataset. Like I said, I'm not gonna reinvent the wheel here. This again is like the hello world of machine learning, but this is what the code looks like. I'll zoom in for all of you. So as you can see, we're utilizing Torch Vision. Torch Vision has data sets built into it, which is also really nice. So it has the MNIST data set that we can get from here. I'll quickly walk through what each of these mean. This is all in Python, obviously. So first is your net class, pretty intuitively named. That is your neural network. This is the algorithm in which, this is the algorithm in which the neural network is initialized, but then how data steps through it. So forward is essentially how the tensor array or how the image will pass through the neural network and how it will be trained. You can see here. So then this data loader, this is where we actually access the MNIST data set and we start to load it into a data loader. It's a little bit difficult to understand, but you have this data set and the data loader makes it iterable, makes you be able to index over it one by one. So you essentially say, I want to get all of this information, I want to transform each thing to a tensor, normalize the tensor, and then load it into a data loader so it is ready to iterate over. Similar with tests, but again, this is used later once you've trained. And then averaging gradients, that's kind of a part of the algorithm that you utilize to train your data. But then you have this train function where you would utilize your neural network that you previously had defined before, and then you walk through training it. You walk through putting the data through it, getting the result, getting the margin of error, and then based on that margin of error, back propagating, optimizing, and then moving forward with the next entity of data. So you can see here, we're creating the model and we're training it. These are the epochs, so this is, again, how many times you go through training it, optimizing, like I said, and then ultimately testing. So there's a lot here. It can definitely look intimidating at first. By no means do I have any of these algorithms memorized or know them, but as you start to read through different algorithms in machine learning, and especially on images, for example, and how to train them, all of this is very intuitive and step-by-step. And mathematical as well. So PyTorch has a lot of this built in again. There are different ways to implement this neural network, but this is just the example that SageMaker hosts for you. And then ultimately, you have this main where you can take in different fields and change different things, saving the model as well. So you can definitely do this yourself. I did in that blog post that I mentioned. Mine was much more similar, much more simple and much less accurate than this, but I'm utilizing this one because it was more accurate than mine. But again, ultimately all of this has been researched and documented, and as a programmer for you, this code is standard, and so a lot of it is copy-paste at times. So all of that's to say is, by no means do you have to memorize any of this. We have these examples for us, and as you step into the code and maybe debug what some of this looks like in Colab or in your own environment, you can see what it does and optimize it for your own thing. But that's the code. This is the example that we're going to use. I'll quickly share this in chat if you want to follow along, but like I said, it's all in that blog post. If you want to check out the blog post, I'll link that as well if you want to follow along. But with all that in mind, if there aren't any questions about the code, again, don't need to know all of it, don't need to memorize all of it. We're going to step into Amazon Web Services, AWS. So I've already logged in. I also already have this project built from when I wrote the blog, but we're just going to start from scratch, so you might see me having to delete certain things just to reduce duplication. But like I said, we're in the Amazon Web Services console, and I'm just going to search for SageMaker. And again, SageMaker lets you build, train, test, deploy your neural networks. We're, like I said, going to utilize that example that is on GitHub, and so we're mostly just going to deploy our models. So before I step into doing this, I would be doing a disservice to you all if I didn't say that this is going to cost money. There is a free tier for SageMaker, but SageMaker is pricey, for sure pricey, and so whatever you do, you want to be very, very careful. This specific example, after testing it a lot and iterating over my neural network a lot, making sure it worked, and then also connecting it to my web app, I think at the end of the month it cost me just shy of $35. My first bill, though, was very, very expensive. It was upwards of $300, and so I've definitely tinkered around with it enough to get it to be as cheap as I can. Again, there's a free tier. I probably already passed the free tier, so for all I know, this will be entirely free for you. But I just wanted to make that caveat before we keep going. All that is to say too, Amazon has really good customer support. So if you mess up and get a really high bill, you can always talk to them, and they almost always remedy it. Not that you should take advantage of that system, but sometimes, hey, we don't know what we're doing. So making that caveat, again, if you have any advice about making your AWS build cheaper, or any advice about SageMaker and making that cheaper, please let the fam know, let me know. I would love to know how to make this cheaper. I mostly just tried by guessing and checking different things. And fortunately I'm able to expense it. So you have been warned. All of that is to say. Okay. So the first thing that you want to do when you're in SageMaker, this is your dashboard. We're going to be utilizing a notebook. So you can click on notebook instances here or on the left-hand menu. So these are my different notebook instances. This spy hack one, if you are interested in that's what I did in my Detectron 2 video, which you can also check out. And you can see I have like these 3 things for this Pi app. We're going to ignore all of that though. Notice that all of them are stopped, because if you're not using them, you should stop them so you stop getting charged. So if you're following along, again, stop what you don't use. That is a great way to keep on track of your AWS bill. So I'm going to create a notebook instance, and I'm going to name it, we'll call it, I already have a PyTorch Pi one, so we'll call this one PyTorch SageMaker. Maker Pi PyTorch Sage. Sure, you can call it whatever you want. Honestly, nobody is probably going to be looking at this anyway, so YOLO, let's just do that. Next, I'm going to be doing the medium tier. Do not do large, do medium. Medium is the cheapest that we can get away with. If I'm not mistaken, I believe that T is also right. So ml.t2.medium is what you want to use. Elastic inference is none. Don't worry about this additional configuration. Next is the IAM role. So the IAM role, if you aren't familiar with that, some people call it IAM, I call it IAM. If you're not familiar with that, it's essentially a role you can assign yourself to give you different permissions across AWS, permission to use different services. So for example, if you have multiple people in your organization, you can say, hey Bob, I only want Bob to have access to SageMaker and to Lambda. And then when you create applications or instances with that specific role, maybe it's specific to Bob, maybe, I don't know, it's specific to a product, they only have access to those services and no others. So with the IAM role, I'll just create a new one so you can see. You want to say any S3 bucket for this example. If you do this in production, you probably want to do specific ones, but for now I'm just going to say, hey, you can have access to all of it. Any bucket with SageMaker in the name, sure, why not? YOLO, let's create the role. So again, creating this new role just would let you then, when you want to go to the IAM console in AWS, you can edit these configurations however you want. No custom encryption, definitely enable the root access. Don't worry about network, don't worry about Git repositories. Tags, totally up to you. If you want to tag it as different things, you can. all that looks good to me, so I'm going to create the notebook instance. And this takes time. Pro tip, if you don't refresh, it'll probably stay on pending for a while. So I would refresh every minute or so. And then you can come back and double check, obviously. I think while this is pending, I'll just quickly show you where this exists in IAM and how to manage that. So with IAM, you can click on roles, and then you'll see, ooh, gross. You'll see the last role that I created is here, and this is where you can attach different policies to it and whatnot. So for example, I'm probably going to use this role with my other services. So I'll quickly just add, for example, API gateway, full access, administrator and full access, I'm not sure what the difference is. So I'm adding API gateway, and then I'll also add Lambda, full access. Basic execution role also works, so YOLO, let's add both. You can also add many others. If you wanted to use a database, you can use DynamoDB, full access, why not? But again, totally up to you. I'm just going to quickly attach those policies. Oh, gross, my sister's here. LOL. Hi, Cassidy. Thanks for watching, everyone. You all are awesome. Okay, so now attach those policies. So this IAM role has access to all of these different things. The other thing that is worth mentioning is S3. S3, I kind of dump a lot of stuff in S3. So you can see I have SageMaker, but whenever I need to host something, I almost always put it on S3. It's just easy. You can append a URL to it so it's accessible. It's really easy to set permissions, but this is kind of where my data will be stored for the neural network. I've never incurred costs with S3. Their pricing for S3 is amazing. So definitely big fan of that. Let's check on our SageMaker instance and see where we're at. So we'll go to notebook instances. It's still pending. Cute. I guess I can go through some of the things here. Again, we have the IAM role and ARN connected. I don't know what ARN stands for, but this is important and we'll use it later. It's essentially, I think what it is it helps. Oh, thanks, Alexis. Alexis, okay, whenever I hear or I see your chat, I always think of Alexis from Schitt's Creek, the show. If you haven't watched it, check it out. It's a great show. But thank you. I appreciate it. Yeah, so anyway, ARN, almost every instance you create on AWS, I think it's safe to say every instance you create on AWS, has an ARN associated to it, and it's just an easy way to connect things and have them talk to each other. Okay, so now we are in service. Woohoo, super fun. Once it is in service, you can go ahead and click Open Jupyter right there, or it's up here. If you click on the actual notebook instance, you can open Jupyter or Jupyter Lab. I always do open Jupyter. That will take you to this directory in Jupyter Notebooks, which you can see here, and it's currently empty. So then this is Jupyter Notebooks. If you're not familiar with this, this is essentially unique to my AWS instance. Conda, if you're not familiar with Conda, it's kind of like pip, but I've only seen it used in the context of machine learning. So you can add different Python packages. I almost said PyTorch packages. You can add different Python packages here through Conda and search for them. It already has a ton built in already, so chances are you won't need any. But right now, right now I want to upload these files from GitHub to Jupyter. So I'm sure there are very quick ways to do it, but I just get the raw text and then oops, and then create a new file. And I'll call this, yeah, make this a text file. Paste all that in, keep the license, it just makes folks happy, and then we'll call this index.html. Okay, so you'll see this being used a little bit later, but the index.html is what we will use to draw our handwritten number. Yeah, I think that's good. So now it's here. And then we'll do another one, I believe, yeah. I'll go get the raw of the Python file. So this is our neural network code. If anybody thinks there's a more efficient way to do this, I'm all ears. And this.py, did I spell that right? And this, yeah. Okay. So now that exists. And then finally, we want the runnable file. So the runnable file is this .ipynb. So like I said, it's just runnable, and this is going to give us metadata. And I think I might, yeah, I'm going to do PyTorch 3.6 here. So then this will create a new runnable notebook for me. Again, it's similar to Colab. I think I can import my metadata. If I can't, that's no big deal, but it would be great if I can. No, okay, I don't think I can, so I actually am pretty sure I have this already on my computer. I just have to do some digging, and then I think I can find it under GitHub. Oh shoot, did I not? Oh, that sucks. Okay, that's fine, whatever. I can just do one for one, or quickly get the repo and then clone it and then upload the file. I'll do that. And I'll show you all my terminal. Okay, so let me quickly oh, I can just download the zip. Oh, that's fun. GitHub, so reliable. So we'll wait for this to download, and then unzipping, and then I'll just upload that runnable and show you it running. And I know that that's going to take a while, so I'll explain. I'll click run first, and then I'll explain what each code block does. So where were we? SageMaker, Python, PyTorch, MNIST. PyTorch, MNIST, and get that runnable. Okay, so now we're uploading and it exists. Yay! Okay, so I'm going to, I believe I don't have to change anything in here. Let me just double check. Okay, I do. Okay, so if you're following along, you'll see that the instance type here is large. Remember, we didn't do large, we did medium. So quickly just change it to that t2.medium. And then I'm going to scroll down and click the delete endpoint because I know I'll want to not delete it and keep using it. So I'm just gonna hit run, wait, run all. Okay, so if it has a star next to it, it's running all of the cells. Okay, so yay, we're here. Let me explain step by step what each code block does. Again, this takes a really long time. It will probably Oh no. Oh, that's probably fine. That's probably fine. Yeah, it's still working. Okay. Yeah, like I said, again, this takes a long time. It might take 20 to an hour. It's training our neural network, building it, and getting it ready for deployment. So sit tight. But I'm going to hopefully it does finish running and it just goes really, really fast. If it doesn't, I'll explain this and then we can start working on the other pieces. Okay, so essentially we have those three files. We have the input.html. Oh, I called it index. Oh, hopefully that's not a problem. It'll be fine. We have the input.html, which again is the code that will be run. So when the model is finished building and ready to experiment with, that is where we'll draw our numbers. If you can read HTML, you can see we have that canvas here, and that's, again, just code to draw that. We'll reference this later when we build our web app. Then we have this MNIST, which again defines our neural network and how to train it. And then finally, we have this runnable notebook. And this runnable notebook is essentially where we're going to tell SageMaker, hey, build this neural network, run it on the data that we've defined, and then create a SageMaker model instance that we can create an endpoint to utilize in different services. So this might not be the right way to think about it, but this is how I think about it. SageMaker is kind of like API gateway. It's kind of like creating an API endpoint for models. And so that's what we're doing here. The thing is, those endpoints are only accessible in, I believe this is correct, they're only accessible in other AWS hosted code. So you can access those endpoints that are made from SageMaker in Lambda, for example, which is why we're going to create a Lambda service as well. But otherwise, if it's not also hosted on AWS, I'm pretty sure that you can't access it. I only speak to my own experience. That is what I've experienced, and this is the process that I've figured out and works for me. If you figure out something else, great. Share with the fam. Love to hear it. But okay, so all that is to say, let me go in here so I can make sure everything is running properly. So we import SageMaker and we start a SageMaker session. This is all just saying, hey, we're pointing to the SageMaker instance that we already defined. Then we're getting the MNIST data similar to how we did previously. Again, you're getting the data set from Torch Vision. Downloading it, that means it's being downloaded to that S3 bucket that we previously saw, and transforming all of the data in that data set, all of those images to tensors, to those 128 by 128 arrays that'll show zeros and ones, zeros if it's white space, 1 if it's black space. Uploading to S3, like I said, again, we downloaded that data. This is just defining the S3 bucket that it should be downloaded to. You can see that these are finished running because they don't have a star next to them, which is great for us. And then we start training on our MNIST model, on that model that we had previously defined. So all this is to say is we are getting, at this point, the model ready to run. So here, this is where we start training in SageMaker. So SageMaker has a PyTorch library built into it. This is how we can define the training entry point, instances, and how much how many times we want to train the model. So the default epoch is 6. Again, you can do more if your accuracy isn't great, but 6 is good enough for me. Looks like we had an error here. Oh shoot. ML T2 is not right. Oh, shoot. Okay, so according to this, actually, maybe I don't have to change this. I'm thinking that this train instance type is exclusive to the model, which is probably fine. So I don't think I had to change that. So I'm going to run this again and then run all below. Yes, and we'll keep going and hopefully that doesn't take too much time. Okay, so like I said, we're defining this estimator. So the estimator is essentially what we're going to use to deploy the model, and then we'll get this predictor object. So the estimator is saying, hey, start training, give me information about each iteration or each epoch of the training cycle and let me know what the accuracy is. So you'll start to see here, it'll eventually say, hey, for epoch 1, we had a 90% positivity, meaning that there were only 10% of the data gave us errors. And then with each epoch, that success percentage will get better. So, if by the end of the epochs, let's say our estimator was only at 80%, then I would just run this again, maybe increasing the epochs to say, hey, let's get better. Once I have an accuracy or a confidence that is good enough for me, usually for me it's like above 90%, then we will create the SageMaker endpoint, and that is creating this object called predictor. That is to say that, oh, maybe this is where I meant to change it. Yeah, this is where I meant to change it. Okay, so this will probably break, but this is where I meant to change it to T2 medium. Okay, so this is directly referencing my SageMaker endpoint. Yay, that makes sense. So again, once the estimator is done, this is the thing that takes a long time. We'll create this predictor object, and the predictor object will point to the model. So then, when I draw things in my HTML, which you'll see here, I'll just quickly, I'm pretty sure I named it index. Once this is done running, you'll see a little canvas that I can draw on. We convert that to a NumPy array, which is essentially a tensor array. NumPy, I think it's NumPy. We convert that to a NumPy array and then put it through the predictor, which runs predict on it, which means it runs it through our neural network, and then we get an accuracy, and then we can determine if that was correct or not. If it wasn't correct, then maybe we go back, run things through the estimator again. If it looks good, which it probably will, then yay, our notebook is done running. We have trained our neural network, we have created a SageMaker endpoint, and we can utilize that in other AWS services. Woohoo! Hopefully all that makes sense. You can see right now it's downloading data, it's downloading MNIST, which takes a really long time. But eventually, this will finish and we can run. I also hope that all of you can see this. I just realized it might be kind of tiny. Hopefully it's okay. Let me double check. Yeah, okay, named it index. You can see we're having the data here. Everything is beautiful, working great. Again, this will take a while. So if there are no questions, which it doesn't look like there are, at this point, I will probably go to Lambda, and start to work on that aspect while this is training, hoping, praying that it works. So we can keep this running. Actually, it might be good for me to just show you the pricing model of all of this, just so again you can see. So let me just show you SageMaker pricing model. So blah blah blah, there's a bunch of stuff. We're looking at model deployment, and again we're on MLT2 medium. So you can see it costs about 7 cents per hour that it is turned on. So again, this is why it's very, very important when you're not using it to turn things off, because it actually doesn't matter the space you use, apparently. What matters is how long you have it turned on. And this is for deployment. Again, we're also doing training, which that explains why it broke, because you can only have large training instances. Our training won't take a very long time. Like I said, it'll take max 30 minutes probably, or an hour, so it will probably cost max 13 cents. Processing we're not doing, building we are doing, and it's 4 cents, and that took less than a second. So in short, if you can get this done really quickly and really well, it would probably only cost you a couple bucks. Like I said, I kept mine on and was testing, and it cost me about 30. So just something to be cognizant of. I think for the most part, most of you are watching this to just understand how it works and what the communication process is between a web app and your PyTorch model. And all of this is to say, I'm not endorsing this as the right way to do it, but as someone who previously worked for Amazon, I just know AWS well, and so this is what works for me. If you have other experience with GCP or with Azure or any other cloud hosting services, definitely share with the fam. Let's hear about it. I know there's also a way to do all of this through what is it? Elastic instances? I'm not sure. But SageMaker kind of, puts this nice UI on top of it with Jupyter Notebooks and makes it really intuitive for especially people who have research backgrounds and exclusively work in Jupyter Notebooks to deploy their neural networks or just quickly move things into production. So, okay, it looks like things are happening here with our training. I doubt it's done. Oh, wait. Oh, shoot. Okay, this is probably because I didn't change it last minute. Let me run this. Oh, sad. Oh no, please don't not work. Let's check the output of this training first. It was definitely finished. Oh shoot, I really hope that this isn't broken. Okay, estimator. Let's see. We're live coding. This, of course, would happen. Bucket. Downloading files. Self.coordinator.result. Oh, okay. Let's see what happens. Okay, it also broke. Okay, well, whatever. I'll figure it out. Head object not found. So, I don't want to run all of this again. I wonder if it's because, okay, we have S3. We have the demo. I wonder if I need to change the prefix at all. Didn't seem to find them all. Randall! Oh my gosh, Randall is here! Guys, okay, Randall. Randall just joined my team. He is an AWS Pro. Could be eventual consistently in S3. Try again. Yeah, I don't know. Wow, Randall, I'm so happy you're here. Suddenly, I have confidence. So, okay, we have the S3 bucket. Let me make sure it exists. I'll switch over. I would hate to have to run this again just because it takes a while. We have our MNIST data that loaded properly. Let's see. Okay, I guess I guess I could run it again. I don't want to, but let me just double check things here. The training was a success, which is good. I definitely gave full access to S3. Did I? Let me double check that. Also, I don't know why it locked me out. Let's just double check our role, make sure we definitely do have access to S3 because we've used it already, but is there a policy for S3? Let's just give it full access. And then we'll run this again. Sad. Oh no. I don't know how that happened. Okay, well, I guess I'll run this again. Let's just run it all and see what happens. Sad, but this is what happens when you live code. Of course, there was going to be a problem. I'm just checking on my other screen to make sure that I don't have a S3 bucket that's named the same thing. Because I think that it definitely shouldn't, but I think that could possibly be an issue. Okay, definitely 2. Also, EC2, that's what I was thinking about earlier when I said elastic, is you can definitely figure out how to deploy models through EC2, but I haven't. So we only have 8 minutes left. This is definitely not going to finish in 8 minutes. So we'll definitely keep going. I think maybe I'll just talk a little bit about what we're going to do in the next couple videos, and then kind of set us up for that and keep this running, and maybe something amazing will happen in the next 8. So we'll have this deployed. We'll test it on the input.html on that canvas, make sure it works. We're definitely going to use that code later. The next step is to create a Lambda instance, and in that Lambda service, I should say, in that Lambda service, we are going to create a communication pathway from a request we get from the web service through API Gateway, and send it to SageMaker, and then take the response and send it back to API Gateway. So what that will essentially look like is utilizing the SageMaker library within AWS Lambda service to take the data. We will parse and interpret the data as a tensor, or at least check to make sure we sent it properly. Send it to SageMaker, get a number back from SageMaker, or actually we'll get an array back. That array will have 10 indices representing digits 0 through 9. Each indice will have an accuracy associated to it, and that accuracy will give, or I shouldn't say accuracy, I should say confidence. That confidence will represent how much the model thinks that image related to the number. So for example, if for index 9 it was 99%, then that drawing is probably a 9. So what we would do then in the Lambda service is parse that, send back just the 9, so that way the request only has 1 digit to worry about. On the API Gateway side, we'll handle that funneling communication, but what we'll expect from the web service is an array representing the image, and then in the response we'll send back that number. Then on the web application side, will just access that REST endpoint, but we'll also utilize the canvas in this input.html, make it bigger, scale it, but then also double check to make sure that the array that is interpreted from the canvas actually matches up with the drawing. And that's the probably most guess and check part of all of this. So hopefully that sounds good and that continues to make sense to you. We have about 5 minutes left. I don't think that this is going to finish in that time, so I'll just end early. And I'll say thank you all for watching. I think that this went well. I'm hopeful about our live streams in the future. If you have any questions, comments, suggestions on how this will work, I'm definitely going to reach out to Randall after this because he's our kind of in-house AWS expert. Hopefully we'll figure this out, and next week on Wednesday, same time, I will give you an update on to what the solution was, and we can continue making this web app. Awesome. Again, thank you all for tuning in. My name is Cami Williams. Don't forget to subscribe, and I'll see you next time. Bye.